we've got a car or an object, and we've got to use Dalembert's principle. We've used conservation of energy before, but in this one, we've got to use Dalembert's principle. So we've got a car or something, and we've got to find the force, the tractive force, traction, the tractive force to accelerate the car from 0.5 meters per second up to 2 meters per second in 3 seconds. So we want to go from, don't forget, U stands for initial velocity. So that's going to be 0.5. So we go from 0.5 meters per second up to V, which is the final velocity, 2 meters per second. And they're going to do that in 3 seconds. So what force do we need to produce to do that? The car is not a very big car, 45 kilograms. Okay, and the force, so we've got friction going the other way. So obviously friction goes against movement. So the force to overcome friction, Fr, force to overcome friction, Fr, is 5 newtons. Get a smaller pen, perhaps. So we need to find the force for that. Now it's Dalembert's principle. So we know that Ft, tractive force, is mg. M is mass, G is gravity, 9.81, plus ma, m is mass of the car, a is acceleration of the car, plus force to overcome friction, which is Fr, which we know. So that there is Dalembert's principle. We're not on a slope, so there's no angle involved, but that's what we've got to do. So all them forces, don't forget Dalembert was looking at forces and acceleration. So mg is weight, look, m times g is the weight of the car. M times a is inertia, Newton's second law, and Fr is friction. So what we're going to do now is, what do we know? Well, I know the mass, yes. I know gravity is 9.81. That's good. Mass, yeah. I don't know acceleration, but I can find it because I know starting velocities, final velocities, and time. So I can find A. So I'm going to put A, we don't know. And this thing is friction, which I do know is 5. So I've got to find acceleration of this car. Got a few formula. V equals U plus AT. That's one formula I could use. V squared equals U squared plus 2AS. That's another one we could use. S equals UT plus a half AT squared. Got to find A. They've all got A in them. These two have got S, which is distance. So I don't know the distance. No, I don't. So I'm going to be using this one. So I know V, I know U, I don't know A, but I know T. So I'm going to rearrange this now. Let's get rid of that so you don't think it's divide by. So I need to rearrange this formula to find A. I'm going to take the U away first. V take away U equals A times T. And then bring the T down. So V take away U divided by T. Give you A. Acceleration is change in velocity over time. This makes a bit of sense. So I know V, I know U, I know T, so I can find A. So A is going to be V take away U. So V is 2 and U is 0.5 and the time I think was 3. So V is final, which was 2, U was 0.5, starts off at U, times 3. Thank you very much. This will give us the acceleration, which works out to be 0.5 meters every second. 1.5 divided by 3. So this car's got to accelerate 0.5 meters per second per second. That's the acceleration. Okay. Now I can go back to my formula, my Dalembert's formula, which is tractive force Ft equals mg, mass and gravity, plus mass and acceleration, which we now know, plus friction, the force due to friction, which was 5, I think. So different color pen. So the mass is 45. So I'm going to put 45 there. Gravity is 9.81. We're on Earth. Put a bracket on that. Plus mass again, which is 45. Times by acceleration, we just worked out 0.5. That 0.5 is there, look. 0.5 acceleration. And the friction, the force to overcome friction, this is Fr, which is 5. So in your calculator, do all of that. Use the brackets. And the answer is 468.95 newtons. That's how much force the car needs to put down to accelerate this car from 0.5 to 2 meters per second in 3 seconds.